My name is Manda Cosmos. I'm the industry lead for buildings and most specifically the higher education space for Trendspek. I'm joined by Ian and Diana from Infracorr. Do you want to say hello?
Yeah, hello everybody. I'm the founder and director of Infracorr Consulting, based in Melbourne.
Diana Soliman, Regional Manager of New South Wales, and I'm also a Principal Engineer at Infracorr.
Fantastic. Today we've got a pretty jam-packed schedule with plenty of agenda items. First, we'll start with who is Trendspek and what do we do. Then we'll go on to learn more about Infracorr. We want to talk a little bit about why universities are such a hot topic and a focus for us at Trendspek. Then we're going to hear from Infracorr, Diana and Ian, about the process before a technology like this and now. And then together we'll discuss some of the benefits of a digital approach. We will have a live Q&A at the end. So you'll find that there is a Q&A widget to the right-hand side of your screen. Please put as many questions in there as you can. If we don't get to answering them while we're live, we will have your contact information. So we'll share an answer with you directly via email. The session will, of course, be recorded, as I've alluded to, so you can replay this at any time. If you've registered, you'll receive a link and you can share that link to anyone within your organisation. They'll be able to view it as well. So we want to make this as easy as possible. Please ask as many questions, share as many comments as you can, because this is for your benefit as well as ours. We will start off with who's Trendspek. If you're not familiar with us, we're a software company. We make a software that helps digitize any built structure. We're utilised in a diverse range of industries. We've got container cranes, we've got skyscraper bridges, and of course some really beautiful university buildings across the world in our platform. We started off the back of a need for organisations to conduct safer, more cost-effective and more comprehensive asset inspections. And what started out as a visualization tool has snowballed and turned into not just digital inspections, but an asset management software that can help you across the life cycle of your asset, whatever it might be. But of course, today we're going to focus on university buildings. We work with customers all around the world, and what we want to do is provide remote, safe and digital inspections. And once that inspection has been conducted, we want to be able to help streamline your measurements and your maintenance workflows. So instead of having many, many people out to site many times, we are enabling organisations to do what they would do on site much faster and much safer, while collaborating with multiple people across different disciplines, monitoring trends over time, and then eventually looking at predicting what's going to take place across your asset with the data that you've harnessed. We are working quite heavily in the university space, and I think that comes down to a couple of reasons. I understand and we're aware that universities across the world, of course, experience many different challenges, many different, uses for something like Trendspek, but you all have very similar challenges as far as a lot of the time you're looking after a portfolio of many mixed assets with varying ages, varying materials across multiple campuses, sometimes in different states, different countries. Now, having the need, or I suppose the desire, to harness the data across those multiple assets, you've got a 100-year-old heritage building that's probably aging at a similar rate sometimes we see with 10-year-old assets, just because of the materials that they're built of. It's hard to harness all of the data and have an understanding and make strategic decisions moving forward. We also understand that your organisations are open to the public and you receive a really high volume of foot traffic on site, which increases the risk of having multiple people, sometimes thousands in a day, on site. We see that universities are needing to compete with other universities across the globe in such a small and getting smaller pool of international students. So you need to harness what you've got and make the most of it. And then, of course, be able to keep up and keep agile and flexible when it comes not only to timetables and spaces, but the education offering. And then switching it up, underutilized spaces needing creative solutions so that we keep people in the on campus as much as we can. So we think that Trendspek is a really suitable solution to help with some of those challenges. And I'm going to hand it over to you now, Ian, to introduce us to Infracorr.
Great. Thanks, Amanda. Look, Infracorr, I founded the company 21 years ago now, and we're specialist engineers, and we investigate and diagnose structures of all sorts, buildings, bridges, wharves, jetties, bridges, etc. And we're effectively durability and structure doctors, really, in terms of materials engineers, civil engineers, a mixture of other specialists. We effectively, by investigating the structures, can determine what is the cause of any deterioration, how quickly a structure needs some assistance. And just like us, all structures deteriorate and need TLC to maximise their life. So by investigating the structure and knowing a lot about different materials in terms of whether it's concrete, steel, aluminium, sealants, etc., we can predict how long things will last, and obviously can inspect and determine how we need to repair and maintain these structures. So effectively, a lot of specialist equipment, a lot of very, very talented engineers and specialists looking at a whole lot of different materials, and then developing repair specifications and then ensuring the works are carried out well. So it gives you an understanding of us. We literally operate mainly out of our Melbourne and Sydney offices, but effectively, as you'll see with the Trendspek system, we are now operating all around Australia, and quite frankly, can also operate anywhere in the world in terms of inspecting structures. And we are doing so in UK and Europe now. Hopefully that gives an idea of what we do. In terms of how we used to do our investigations, or in the past, of course, we do need and have needed to get up to these structures, and we have rope access engineers, a lot of cherry picker use, a lot of camera use from ground level with telephotos, etc. And typically what we might be able to inspect with these sorts of techniques is it's very slow, and usually you would only inspect maybe 5-10% of a structure or a building. And then you're trying to then interpret what the rest of the building is like compared with the areas you've managed to inspect. Obviously, working off ropes and cherry pickers is far more dangerous than working from a computer screen, as you will see when we get to the Trendspek type scenario. So with Trendspek coming along, we've been working now for about 4 years with Trendspek. The structures can be captured with drones or handheld cameras, and effectively the images are stitched together into a 3D model, so that we can literally inspect any aspect of the captured model from a computer and zoom in as if we were touching the building or the structure. So literally we can go anywhere on the roof, on the facade, anywhere on the structure, and look at fine detail of what is the issue. Maybe it's a safety issue, maybe it's just deterioration, maybe it's just a point of interest. And everything here on the models are to scale. So unlike a photograph, which you can't scale off a 3D model because it's all GIS captured, we can scale off and measure any distance. And anytime we mark a defect, it is located in space. So we know the latitude, longitude, and elevation of everything we are looking at. So we are going to look at a little bit of a couple of case histories. Effectively, drone use is very big part of how we capture the models, but we're also using handheld cameras as well. In this case, we're just looking at a water tower to show how we can now inspect in great detail and how we mark up the defects or anything of interest. So once we've we just lost that video, Amanda, thanks for that. So once we have captured the structure, again, the 3D model is completed by Trendspek, and you'll see here that any defect we mark can be labelled or has its own label, and those labels can be turned on or turned off very quickly as required. And then you can also show each of the camera positions. Each of these yellow dots is a camera position with a high resolution photograph. So you can see we've got a very good coverage of this structure. You can actually even click on one of those photos and you are then looking at a 2D photo. But we are generally more interested in the 3D model. And of course, now we can go and inspect any defects at close detail. And our engineers simply zoom into the areas of interest. We can look at areas of leaking, as here, efflorescence from the water tank. That defect now is marked and recorded as T20 in this case, and is effectively entered the database of recording of defects. We can look at any corrosion issues, cracks, any areas of interest. Again, as soon as we mark them, either as a crack, for instance, a line, a point, or an area defect, it goes into the database, as you can see on the left-hand side of the screen. Once they're in there, you can click on any of those defects. It will fly to those defects, such as this honeycomb concrete and cracks that we've recorded. And these are permanently recorded, and we know where they are in space. And also any of your interests like corroding brackets, anything that's causing us concern, or any maintenance items we want to highlight. That can also be prioritised as either urgent or low activity or low urgency. Here we have a concrete spall, concrete cancer, if you like, and we are highlighting the area of that spall. We now know the area and the surface area of that spall, where it is in space, and we can look at that defect and also look at it in time. So now we have both a more recent capture showing the same area, and anywhere we look on the model, you can look at the same issue in its repaired state. And so we can even superimpose those over the top of each other, so you can literally look at the previous versus the repaired state of the structure. So we have then a permanent record of any repairs, and at any time we can actually look at these issues. So hopefully that gives you an idea of how we do the captures, and now we're going to look at a few other structures, and Diana's going to talk to the University of Sydney.
I might firstly just introduce the case study itself. You can find it on our website, trendspek.com. We have been very lucky to work with the University of Sydney, with more than 100 buildings being recorded and modelled into the Trendspek platform in their Camperdown campus. We were able to achieve, of those 100 plus buildings, about 80 to 90% external coverage of every single structure with the use of drones and other capture methodologies. And working very, very closely with the project team at the university, we were able to do this and minimise the amount of disruption caused for the students, the academics, the teaching staff and so on, doing these types of things on weekends, during the uni breaks and so on, to ensure that we were not, having to cover buildings in scaffolding, for example, with a uni that I worked with, I think in SA somewhere, who did so right before their open day, which was a little bit of a disappointment for the team there, but able to do this across such a large portfolio of buildings, and of course doing it remotely with our friends at Infracorr. So just to set the scene for the work that we did there, I'll hand it back to you, Diana.
Thanks, Amanda. As you can see, the drones that we've got here are capturing the building from the top side with the high resolution cameras. This is our beautiful quad building at Sydney University. Now, each image is captured. It's got its own precise location, and you can see all the yellow dots here are showing the positions of the cameras around the structure. Each one is typically 45 megapixel in size, so it's very high resolution. Now, if we right-click on one of these, we'll be able to see the 2D image, and then we'll be able to zoom in and really assess this structure and have a look at it from all different aspects. It can tell us all the fine details of any particular area that we choose to zoom into. We'd also be able not just to see it, but also to measure the exact size and location of any defects, whether it's a crack or a spall or even a missing window sealant, for example. we can also do that through this Trendspek platform. Now, in general, what we found out is that the model helps us a great deal in getting a better understanding of the building itself, as well as any other issues or concerns that we may possibly have. Now, with each defect and element classification, it gets recorded into the database, and then it allows us to report and export and print as needed all this information that we've captured. The model and the defects can then be shared with asset owners, consultants, or contractors as required. We give each person a viewing right, which helps them do the work that they need to do. Thank you.
Right, for inspecting newer or more modern buildings, we obviously can get a view of any aspect of the building. Previously, as Amanda said, classically at Sydney Uni, probably 80 to 90% was captured. Mainly trees are the issues of that do block our views in occasions. So that's where we might bring out the handheld cameras, etc., to look around these trees, etc., to increase our view. But we can look at any particular areas like roofs, facade elements, or mechanical equipment, etc. So we'll just have a look at a more modern building again at Sydney University. And in this case, I'm just going to highlight a roofing area of interest that we can inspect. In this case, we're looking at rust staining on some roof sheets as well as some sealants. And we could look at this in fine detail. Again, that would go straight into the database and be able to be shared with perhaps a roofing contractor or effectively ability for any maintenance work to be undertaken. Here's a relatively flat section of roof, and because we know the location and the elevation of everything we're looking at any point, we can actually draw a plane around this roof, and again, Trendspek can actually study the surface level deterioration or the surface level movement. So this effectively flat roof, you can see here from the different colours that it is out of plane. And we can determine here that yellows and reds are below the average plane. And if you zoom into that location, you can actually see the very small writing, but tell you what deflection that is below the average plane. The blues will be above the average plane. And literally you can determine from this sort of thing where water might pond on a flat roof or on a flat area. And literally very, very useful for looking at deflections of structures. You can even do this on sloping roofs effectively. So once we've looked at these defects, we order the defects into areas of interest. For instance, it might be looking at the external waterproofing membranes, louvers in this case, or other elements such as the metal roofs, masonry areas. And so all the defects can be ordered. And again, it helps us to pass this information on to perhaps the university asset repair teams or external contractors who could be shared with the model again, and they have perfect access to look at what they are up against in terms of any repairs or maintenance work that might be needed. Thanks, Manda.
Thank you very much, both of you. So to round out the work that we've done, not only with the University of Sydney, but with a growing list of institutions across Australia, being able to understand, capture and predict using data from historical inspections done through the Trendspek platform, you're actually able to predict and maintain the proactive side of things. So looking at a crack that might have been of a very low severity when the first pass capture was done, it's now kind of deepened or widened a little bit in the next time round. We can predict, this one is still okay for today, but it's going to need maintenance, in the next couple of years. Maybe put that on the backlog, for example. We've also been able to reduce the physical safety risk associated with abseiling, cherry pickers, actually physically accessing roofs. enabling people not only to access the platform sometimes from, the couch in between dropping off and picking up their kids from school, but collaborating. I know that Ian and Diana have done many Teams meetings with various contractors, able to get quotes for remediation on various types of assets. And then having access to this type of information, not only receiving much more fair and even quotes from contractors because they've been able to measure something to the millimetre, but now being able to plan the remediation and the scope for future maintenance works, repairs, capital works, and so on. So there's much more that you can do if we zoom out from just one building one time, being able to look at things and see trends over time, predict what needs work and what doesn't. That's where we see, a whole campus or a whole university getting the most benefit from this type of thing. Now, that was the prepared content that we had from you. I have a couple of questions that I wanted to ask, and I think we might have a couple in the Q&A panel here, but I'll start with my ones. These are the ones that come up probably the most frequently. The first one was for you, Ian. Are there cases where you will still need to physically test an asset? Please and thank you.
Absolutely. Look, especially with buildings, we see a lot of problems with brick buildings in terms of deterioration of mortar. Bricks actually grow over their lifetime as well, and they can cause cracking and movement of bricks. So often we do have to inspect and understand what is going on with these sort of movements. The other main one, of course, is concrete. Concrete cancer, a lot of people have heard of, is reinforcement corrosion. We can test these concrete structures, and we need to test these concrete structures to determine the depth of the contaminants, commonly either chloride, salt, or carbonation, and we need to determine the depth of the reinforcing steel and the quality of the concrete. Once we've done these sorts of tests, we can pretty much predict how long a particular concrete structure has before it is going to have problems. So it's very predictable. And so usually we would like to do this sort of testing on representative areas of the concrete or the structure as well, to be able to see what is actually going on, and then we can literally put on some protective coatings, hopefully in time, or we have more advanced techniques such as cathodic protection and anodes that can be used to help stop or to turn off these sort of corrosion issues, because we are corrosion experts as well as part of what we do at Infracorr.
Okay, so would you say that having the 3D model of the asset helps target where you need to physically touch and tap?
Yes. So the interesting thing is, especially with concrete, we spend more time looking at testing the areas that look good, because the real problem with concrete structures is what you see in terms of deterioration is only a fraction of what you've really got. It's a bit like an iceberg. So we test. We know what's going on if we see a concrete spall or a crack. We spend a lot more time testing the areas that look in reasonable shape, and we can start to get an idea of how extensive the actual hidden problem is. And so what it allows us to do with Trendspek is target our areas we want to test. It also greatly assists us in highlighting any areas of safety concerns, either with brick or concrete or whatever, to make sure we can direct the university's asset teams, for instance, to go and remove any defects that might be a fall risk or a concern for any pedestrians, etc. So we can usually we are advising the universities the same day as we find these issues that there is a concern here, and they can be acted on extremely quickly.
Okay, we've got a couple of good questions here from Christy with a K. I might start with the second one. We mentioned 10 to 15% using rope inspection. How long would you typically have had engineers on site in the past? That's a good one.
Diana, you can talk to that one. We've done a lot of experience with Sydney University with rope access, and of course, I think classically a typical inspection off ropes for a building might be a couple of days, but usually I would have said you might only get to 5 or 10% of the building from a 2-day inspection off ropes.
Yeah, that's pretty much accurate, Ian. It would take a lot longer for physical inspections to be done, obviously on ropes for an entire building. So if we're using ropes, we'd be using a targeted approach. We'll look at a couple of elevations, for example, and then we will just make an assumption that the rest of the elevations are pretty much in the same condition. So with the Trendspek, at least we'll be able to assess the building overall, all the elevations, and find out the extent of the defects or the deterioration that we can see overall.
Okay.
And of course, I think with very sloping roofs, especially on some of the historic buildings and steeples, etc., we can see everything, and it's very, very difficult to get to some of these locations with cherry pickers or even rope access is extremely difficult.
Okay, we've had a really good question come in from Bill here. Could thermal imaging help find air voids in concrete to help find drummy areas with the insulating property of the void showing up as a different temperature?
Yeah.
I'm glad
you went
ahead because I don't understand the question.
Yeah, so in fact at Sydney University, every building was in fact captured with a thermal camera as well. And this gives us different temperature gradients of the building. When it comes to concrete, a delamination can effectively happen when the reinforcing steel is corroding, and we can get areas that start to separate from the actual concrete mass. These areas cool more quickly, and so if we capture the image at the right time, we can actually see areas of concrete that are defective. And thermal is also very, very good for anything that's wet, because again, anything that's wet or holding water will usually be cooler, and because it's the evaporation of that water will be cooler, and so we can actually pick up areas of concern from perhaps leaking areas, etc. as well. So the thermal imaging can be very, very useful in some cases.
Wonderful. Thanks for that one, and thanks, Bill. I'm going to need you to break down what drummy means, because that's new terminology that I've never heard before.
Yeah, drummy, when concrete reinforcing steel corrodes, the spore, you saw the photo of the spore previously, where the reinforcing steel is corroding. The rust product is maybe 5 or 6 times the volume of the original steel, and it literally pushes off the cover concrete. That is what a spore is. Now, some of these spores can be literally quite extensive. The concrete perhaps hasn't fallen yet, but literally is pretty much detached. And if you hit it with a little hammer, a tap hammer, it sounds like a drum. It's actually hollow. And there's an air gap. There's an air gap next to the reinforcing steel. And so very common when we're doing our investigations that we are using ground penetrating radars to determine what the depth of the reinforcing steel is, how deep it is. A little tap hammer can give you a good idea if there's any delamination or drumminess. And that's a good sign of reinforcement corrosion that may not be always visible. And so we do this sort of testing as well as some of the other chemical testing on the concrete structures to determine what is the extent of the problem.
Absolutely loving it. And we're getting some good chunky questions in. I'll start with the first one from you again, Bill. Machine learning, is it being looked at for automating defect detection? It's definitely well on its way. AI and machine learning are a really, really interesting part of what we do here. If you imagine running a script or an algorithm for many, many different types of concrete of varying ages with different physical markers, brand new concrete looks different from concrete that's been laid 20 or 30 or 50 years ago. So the algorithm needs to be instructed specifically for what we're looking at. And if we had enough, let's say we had 100 buildings all built with similar materials at a similar age and so on, the one script could be used for all of them, and that would make lives a lot easier. I think from an engineer's perspective, though, we wouldn't want to sign off on a condition assessment purely solved or developed by AI, right, Ian?
Yeah, so we're doing our first trial with Trendspek now on some of the AI, and concrete's probably, as you say, probably one of the most difficult because there's so many different textures of concrete. But what we're doing is literally using the previously marked up and annotated models to actually train the AI. And we're doing this on a number of different structures with Trendspek now, and that's looking extremely promising as a way of addressing, once we have the model, basically addressing all areas of concern. So that is very exciting. I think we'll be able to talk a lot more about that in the next 3 to 6 months.
Beautiful.
As to how this is coming along.
Watch
but
this
it's
space.
looking very exciting.
We might have to do a part 2. We'll catch up in 6 months' time and understand how the project went. We've got a question from Con, I'm guessing over at Adelaide University or soon to be. Are you able to share an example where the imagery has been used by consultants in collaboration with quantity surveyors to develop a bill of quantities for the required remedial works that would support Apple's comparison of tender submissions, with the only differential being the tenderer's methodology, the world's longest sentence? Ian, Diana?
Diana, go for it. Otherwise, I'll have a go, Diana.
While I catch my breath.
Look, we do that all the time, Con. So we work with the universities usually to come up with an estimated sort of quantities for repairs based on the inspections that we carry out. And then that gets shared with the universities, and it gets shared with contractors, I believe, as well. And then they also get access. So all the tenderers or contractors get access to the models that we've looked at, and they're able to look at it themselves and have a look at the quantities themselves and measure it if they need to. On that basis, that gives them the same same place basically as the rest of the tenderers, because everybody has the same platform. They're looking at the same 3D imagery of the building or structure, and they all have the same information. So based on that approach, everyone comes up with their own different methodologies of how they intend to do the repair works. But the quantities themselves, they're all measured up and ready for them to basically work on.
Yeah, just regarding contractors, we're now running a lot of contractor site visits on the models on the Teams call. So, for instance, during a tender process, we can share the model with each of the contractors, but obviously we can have a group inspection, and compared with going along to the underside of a 10-story building and looking up, compare that with actually being on the model and to be able to zoom around and look at these issues. Effectively, you've got contractors then who have a far better idea of what they're faced with, not only on how to access it and to get to these areas, but also they can then be shared the model and literally understand, okay, well, I'd have to do this sort of scaffolding here to get to this location, and or that sort of repair is going to involve this sort of area. So it's totally changing not only the inspection process, but how we actually undertake the works, which is really changing a lot about how we operate from and obviously future captures of the projects of during the work. Even handheld cameras from the contractors can then be, the photos can be built back into the individual annotation as a record of the work that's been undertaken.
That's awesome. Couple more questions. The next one that I wanted to answer, I'll start with myself. Can I also give access to non-engineering teams like insurance regulators or asset teams? This is a really, really good one. This is one that we see maybe beyond that initial inspection. We're seeing asset owners, asset managers, operators utilising the 3D model for so much more. So I've worked with a university who wanted to use the model to just pinpoint where their CCTV cameras were in line with where their floodlights are for students who are roaming around campus at night. And then they can see the areas that are illuminated and then potentially install more lights for, campus safety at night. We work with asset owners who are using the platform to measure that surface deflection to see whether solar panels can be rolled out across different roofs. So this is not just with the university space, but across the board. And these ideas can be utilised in any real building type, I suppose. Roof plumbers can come online and measure up the width and depth of box gutters, for example, to, anticipating heavy rainfall, for example, over a wet season, and just understanding if any work needs to be done. There are so many options for what you can do with the model. It's essentially a 3D model of an asset that could be used for, where's the loading dock? How's the concrete looking on the loading dock, for example? Did you want to add one to that, Ian or Diana?
Yes, I think just on that, just to make it clear that the university is totally in charge of who is shared the model and on what basis they can either view it, or you can give limited ability to actually add additional annotations if you want to, or just a view. The other thing is you can then remove that access to that contractor or that group of people simply by you're in total control of who sees these models and to what level they can actually work with them, whether it's just a view or actually add their own information. So, and remove it when you're ready to remove it as well.
Okay. Yeah, spot on. And Bill, again, has just jumped in with it's great for height safety systems and all the works that go with that. So that's pretty spot on, actually. So there was one other question that I wanted to ask, and I think it might be a nice way to round everything out. What do you think all of this means for the engineering industry and the discipline in itself? Who wants to tackle that one?
I'll have a first go. Look, as a company that investigates hundreds and hundreds of structures a year, whether they're buildings or chimney stacks or whatever, it is totally changing our life in terms of how we undertake these works. So our preference now, pretty much in every case, is to capture the models and then understand what we're seeing in terms of any deterioration or issues, and then working out what our approach may well be and what further testing we might need to do, etc., to understand what is going on with the structure. So it is certainly changing our life from an engineering company specialised in this field of durability of structures.
Beautiful. Diana, do you want to add anything onto that?
I think Ian covered it pretty well. There's nothing left in there.
Nice one.
It has changed our life a lot from, like being able to go to site on a daily basis, looking at different structures has its own safety risks. So, with this model, it allows us, gives us the luxury of staying, being at home or being in your home office and looking at these models from your laptop or your computers on screens, and still being able to assess and do your engineering type of work, but from a much safer location. And then you base your targeted approach or targeted investigations on that, So instead of having to go around the entire building, climbing on ropes and using cherry pickers and whatnot, now you can specify exactly which locations you need to look at and minimize your exposure to other safety considerations on sites and so on.
No, spot on. I think that should round us out for now. Thank you so much, everyone, for joining us. As we said, if you've registered, you'll receive the recording in your inbox. I want to especially thank our good friend, Bill, who has been really, really engaged in the process of getting all of the data ready to go, as well as some pretty cool questions. And I've learned some new things today, so I can add that to my glossary of words. We will be sending out an attendee survey. Please, if you've got a couple of minutes while you finish your lunch, we'd love for you to just share some feedback with us. We want to do more and more of these sessions, and we want them to be tailored to what you will actually find interesting and useful and helpful. So please take a couple of minutes to input your attendee survey. Feel free to connect with any of us on LinkedIn. You've got our details there. that's it from us today. We really, really appreciate everyone spending their lunchtime with us, and we will see you next time. Thanks so much, Ian.
Thanks very much.
Thanks, Diana.